Hey, hey, welcome to season 2 of Officers. My name is Sohan Maheshwar, uh, and I have Tana with me. We're from AuthZed. We're calling this season 2 because we took a bit of a break and we've resumed our live streams again. And today we're going to be talking about observability, metrics, SpiceDB, and Datadog. So if any of these words interest you, stick around. Feel free to ask questions in the chat as well. But largely today, Tana is going to be taking us through the AuthZed dedicated console, how you can get different metrics there, what these metrics mean, and how you can visualize some of this on Datadog. Tana, welcome to the stream.
Thanks for having me.
Yeah, sweet. So I think we can get straight into it. And I know a lot of folks also watch this after we have live streamed. So Tana, I think we can start off by talking a little bit about AuthZed Dedicated, right? What Dedicated really is. And then we'll, slowly deep dive into some of the metrics that you can see there.
Sure, yeah. So starting with what is AuthZed Dedicated, the idea is that we are AuthZed. We are a company that makes an open source piece of software called SpiceDB. You can go and run this yourself. We provide some tools to do that. We don't begrudge it in the slightest. But if you don't want to deal with learning how every bit of SpiceDB works and managing all of the infrastructure yourself, we can do that for you. And we have a lot of practice in tuning and running SpiceDB, and we'll do the work of setting things up and then giving you a gRPC endpoint that you can call, and that is sort of your interface with the SpiceDB instance. And we've got, am I sharing screen?
There you go. Yeah.
Okay, sweet. So we've got a dedicated console, a cloud console, where you can go and do the management of your AuthZed dedicated instances. And this is just one way of managing things. We also are working on putting up a management API that you can interact with Terraform. But right now, this is kind of the primary interface for things. And the idea is that you've got a number of permission systems here. And a permission system is kind of a, you can think of it as like a schema plus some hardware. Each permission system has a number of clusters that are running on it, and it has instances within it. And it's sort of like the top level logical unit for running SpiceDB in dedicated. And then we can click into one of these and see that okay, we've got a couple of replicas. It's been running for a while. We created it a month ago. And all of the management happens in this interface. And this is also where observability happens. So we can go and we can look at the metrics tab here. And I just want to give you some ideas of these are the things that you should be paying attention to when you are operating SpiceDB. And these metrics this is also stuff that's exposed by the open source version of SpiceDB. So even if you're running SpiceDB yourself, knowing what these metrics are and sort of how to interpret them and how to think about them can be useful.
Tana, sorry, can I quickly just jump in with a question? So if I was running
absolutely.
SpiceDB open source, how would I take a look at these metrics, or how would I expose some of this?
Okay, so this is another thing that we're doing for you in dedicated, and that would require a bit of work when you're running it yourself. Each SpiceDB instance, it exposes a Prometheus endpoint, like Prometheus metrics endpoint, that can be scraped by some mechanism or another. So if you're using the open telemetry collector, or you're using the Datadog agents, or you're using Grafana's Alloy, or any of these, or even using Prometheus directly to do the scraping, you would hit this endpoint, pull the metrics in to whatever your system is, and then distribute them accordingly. And then it's a matter of getting them into whatever your observability stack of choice is. So we'll look at what it looks like in Datadog a little bit later. This is our sort of I think we're using React charts for this, but it's very similar to like what you would see in Grafana if you were to take these metrics and visualize them in Grafana. And there's like some implementation details between like the Prometheus endpoint and a Grafana instance that you would need to figure out for yourself if you're running it yourself. And if you're using Dedicated, we both provide these graphs for you and also like provide the Datadog integration that just ships these metrics for you out to Datadog. Does that answer the question?
Yes, thank you.
Cool. Okay, then let's hop into sort of interpretation of some, like what these metrics are and how to interpret them and how you might find them useful. So we'll start with like the first tab is the throughput metrics. And this is showing how many requests a second you're receiving broken down by a few different axes, with the two main ones being the gRPC method that's being called. So like which SpiceDB interface you're interacting with, and then the consistency associated with it. And the way you might use this to just like pay attention to a running cluster is that your traffic is going to have some shape, both in terms of the aggregate over the course of like whatever your like business day is or whatever, as well as a breakdown of like check versus lookup versus expand versus whatever. And just getting an idea of sort of like what the normal pattern is and then what anomalies look like in that pattern is going to be helpful. If you see a sudden spike in throughput, that can be an indication that you may have like a service that is calling it incorrectly or has suddenly started looping for some reason. If you see these numbers crash, that could be an indication that you've got an upstream problem, or that like if you're using our fine-grained access management feature, like if a permission is removed from an access token such that it can no longer call an API, then like you might see that as a crash in a certain kind of request. So just like know what this pattern looks like for your system, and then like you can do anomaly detection based on that. And then the other thing is like talking about by consistency. So this instance is Thumper, which Thumper is an open source SpiceDB load testing system. If you go to like github.com/authzed/Thumper, you can find it there. You can use it yourself to run load tests against your own system. But the idea is that you sort of write scripts and then you run those scripts. And so we've got a Thumper instance that's just making a bunch of calls against SpiceDB, and that's what's generating this traffic. It's also why the traffic is like pretty boring. Like there isn't like the sort of daily swings that you would see with like actual user traffic. And the distribution is very like there's some fuzzing, but it's otherwise pretty static. And you can see that it's making only min latency calls. Ideally, in this total by consistency graph, you're like the vast majority of your traffic should either be min latency or at least as fresh, because those are the two consistency types that actually let SpiceDB use its cache. And that's what's going to give you the best performance. A reason that I would look at this is to see like, oh, I've suddenly got a spike in fully consistent. There's probably some team that I need to go talk to and like teach them how to use SpiceDB and like understand why they're trying to use fully consistent and how else we might work around needing to use that, because that's going to result in much worse performance of your system. And then these other throughput graphs are just different breakdowns, different slices of this same graph up here. Any questions on that so far?
No questions on that so far, Tanner.
Okay, cool. Then let's hop over to the latency tab.
Yeah, I just put in the chat that, I just put in the chat that people may know that SpiceDB is named after, it's a Dune reference, and so is Thumper, right? If I'm not mistaken.
Mm-hmm.
Thumper is also from the Dune universe. So you might find a bunch of things in the SpiceDB cinematic universe named after Dune. So yeah.
Yep, absolutely. So then we have a latency tab. These are just like normal latency metrics broken down by P50, P95 and P99. Mostly they're going to just show how you're performing broken down by which method you're calling. And the idea here is that you really just want to have a sense of what is my expected performance, and then is the latency within those bounds. And if it's not, that's an indication that there's like potential problems and other things that you should go look at. And we'll talk about what some of those other things are when we get further along in the graphs. But this is kind of what these look like, and just like having a sense of what you expect and then how it compares to what you expect. It's a good way to identify problems. It's not necessarily going to tell you exactly what's wrong, but we can step a little further in and get a sense of that. Any questions on the latency graphs?
I mean, okay, so two questions. And one I have a feeling you might cover later. But again, for someone who's absolutely new to the world of observability, performance, what is P99, P95, and P50, and why should I care about it?
Oh, sure. Okay. So the idea is that these are percentiles of latencies. And so you have a whole bunch of, within like a certain slice of time, you'll have a whole bunch of requests that came in, and each of those requests will have a given latency, right? And the idea is that there isn't necessarily a good way to hold all of that information in your head or display all of that information in a way that's sort of like easily grokkable or easily accessible. And so we have this notion of percentiles to give a sense of what the distribution is at any, like for any given slice of time. And so you can see this little pop-up here, and it's showing that the P50 is 2.1, the P95 is 4.1, and the P99 is 5.6. And the literal way that you interpret that is that if you take all of the requests and you just like line them up, like sort them by their latency, then halfway down that list, like the 50th percentile, that request took 2.1 milliseconds. 95% of the way down that list, on the 95th percentile, that request took 4.1 milliseconds. And then 99, like the 99th percentile was 5.6 milliseconds. And then as far as like why you would care about each of these things, the P50 gives you a sense of average. And average is like kind of a fuzzy concept when you're talking about latency, because you can't really discuss an average latency. Ultimately, what this comes down to is the experience of your users interacting with your system. And so you need to like think about how a certain latency would affect that. But you can think about the P50 as kind of the average case. And then P99 is like what we would call a tail latency. So it's the like exceptional or sort of like close to the upper limit of what the latency is. And the reason that you care about that is because even though it's relatively exceptional, the idea is that if a user is interacting with your system enough and like they're using flows that are making check permission calls, then eventually they're going to have an interaction where that 99th percentile latency matters. So like as far as user experience, tail latencies end up having a fairly big effect, even though they are not like average in a sense. So you want it's like giving a sense of the distribution of things, and it's giving you an idea of like what you need to tune. And like the variance between these different things can be interesting as well. So like you can see that like right here we had 127.3 milliseconds for some of our worst requests. And that could mean that it's like, oh, there's one particular code path that you're hitting, or like one particular check path through your schema that you're hitting that behaves badly. Whereas like if you look here, like everything's pretty tight together. This is like probably like this time slice right here is probably your users are happier. So paying attention to tail latencies, trying to diagnose what's contributing to tail latencies can significantly improve your user experience. Any
Nice.
questions there?
Yeah.
I feel like I was talking in
Yes.
circles a little bit.
No, that was perfect. And yeah, great explanation. But we also have a question from Sir Kruder. I'm just going to highlight that. And Sir Kruder asks, is Thumper traffic total by consistency hitting a dedicated performance profiling instance? Or are you hitting live service potentially competing for resources? Good question. And yeah, thanks for joining the stream, Sir Kruder. Good question.
Yeah, so in this case, like this is a staging instance and we're just running Thumper against a staging instance. We are running, like the reason we call this permission system Thumper is because we have like set up Thumper to run against this permission system. Thumper is not something that's included in Dedicated. This is just specifically something that we're using to drive traffic in our staging instance so that we have some idea that like it's our app traffic for our staging instance because we don't have an application. The idea is that if you wanted to use Thumper in your own system, you could set up a dedicated instance, and I would likely recommend not running Thumper against your production instance. Just like don't add additional load where additional load isn't necessary. I would recommend setting up a dedicated permission system and then using Thumper to populate it with data and then make checks against it. And ideally, the way that you write those Thumper scripts mimics enough of what your user traffic looks like that you can get some picture of how your data and how your schema behave in the real world. But I would recommend doing that not in the same system that is serving user traffic. Does that make sense?
Yeah, and Sir Kruder, if you have any follow-up questions, feel free to ask. I can see why calling it Thumper and having, a Thumper here could be confusing to someone viewing this, but yeah, absolutely valid question.
Yep. Okay, so let's step on to the nodes graphs, and this is showing you how much CPU and memory each of your SpiceDB instances is using. This graph looks somewhat silly because it doesn't take a lot of CPU for SpiceDB to serve like tens of requests a second. So you're just seeing a very small amount here. But this would be one place that I would look if I was seeing performance degradation. And I would be comparing the memory usage and the CPU usage to the provisioned compute for that instance. So if I'm running close to 500 millis of eCPU, or if I'm running close to 300 megs of RAM, then that would potentially be a source of performance issues because that's resource contention. So I'm thinking about like where on this graph is my upper limit, and then looking at where it compares to like what's actually happening. And this is also something where like a particularly spiky graph for either CPU or memory could indicate that you just have like, you have a problem child somewhere. You have a like a service that's making a particularly heavy lookup resources request, but it's only happening periodically. Things like that. So this is again something where like most of the time this is a graph that doesn't mean a whole lot, but if you're having problems and you see an anomaly in either of these graphs, that can be something to dig into. Any questions before we step onto the data store stuff?
I mean, I have a question again about this graph. So like when I'm looking at my vCPUs on the y-axis, it says like 0 vCPU, 0 vCPU. How am I supposed to read when like something actually goes below like the x-axis, right? So what's actually happening there?
It's a good question. This is a visual bug in our graphs because this system is using so little CPU that it's like, it's probably like 5 millicores or something like that.
Got it.
So
okay.
We're just rounding down to 0 on the y-axis, and that's not particularly helpful. For a real system doing real work, you shouldn't be seeing this. But again, this is because like it doesn't take a lot of CPU to serve the throughput that we're serving. But if this is something, if you're seeing this or if you're seeing something like this in a real system, let us know. We'll take a look.
Got it.
Okay, cool. Let's step onto Datastore. I would say this is like most of the time, if you're seeing performance degradation of your permission system, the Datastore is kind of the first place to look. And the two graphs that are going to be most important on that front are the CPU utilization of your Datastore and then the number of connections of your Datastore. So first with CPU utilization, for both RDS and Cockroach, my understanding is that you really don't want to be running more than about 60% CPU utilization because that's going to start resulting in contention that causes higher latencies. So knowing whatever your desired headroom is and then comparing the CPU utilization to that desired headroom is the thing that you want to pay attention to here. And you can see that we're only running about 7% CPU utilization. This is fine. I'm not worried about this. But if you saw this spiking up to like 70 or 80%, that would be an indication that you should probably scale your underlying data store up to like get additional performance out of it. And then the other thing is connections. So if you're seeing high latencies and you have you aren't seeing high database CPU usage, you aren't seeing high SpiceDB CPU usage, like an indication that there's just some waiting happening somewhere, then there's a good chance that the reason for that is because SpiceDB is having to wait for connections to become available because it doesn't have enough connections available to it. And so this view of connections is showing you how many SpiceDB connections are open to your data store. And the idea here is that there's going to be some maximum number of connections that your data store supports. You want to know what that number is and then know that this line is below it. And then the other thing is just like looking for anomalies in this graph. It should be relatively flat if SpiceDB is working as expected. It will be periodically releasing and reacquiring connections, but that should be happening fairly smoothly, and this graph should stay relatively level. So if you see spikes either up or down, that can be an indication that there's something up with the way that SpiceDB is acquiring connections. This is also something that in Dedicated, we've done some work recently to make it so that connections are automatically balanced across the SpiceDB replicas that you're using. If you're running SpiceDB yourself, then this is something where you're going to have to know the number of connections that are available for your data store. And then you're going to have to configure the appropriate flags, which are like data store connection, max read open, data store connection, max write open, something like that. And making sure that those are distributed according to the number of instances that you're running. Any questions on those two? And then I can quickly talk about
a couple of questions. So one is you mentioned like knowing the number of connections. So is there a way, like, is that like a trial and error thing where you like, run it and do some load testing and figure out what works? Or is there a way to like know for sure, how many you're going to have?
So I know that there are documented recommended numbers for both RDS and Cockroach. I don't know either of, like, for Cockroach, it's some formula of like the number of nodes you have, the number of vCPUs you have, and then essentially like there's a number of connections that each vCPU can manage. And so you just kind of multiply those three numbers together and you get the total number of connections that the cluster can support. Not somewhere in Cockroach's documentation. And then for RDS, it's, from what I understand, is basically a Postgres limitation. And there will be some, that is documented somewhere for RDS. Again, I don't know it off the top of my head.
Yeah. We can Google that. Yeah. Gotcha. Okay. One is a quick shout out, folks. We're doing this live stream, office hours format. So if you have any questions or any comments, put it in the chat. We're talking about observability, AuthZed Dedicated, SpiceDB, and eventually Datadog as well. And yeah, welcome to the stream, those of you all who just joined. Another question for you, Tana, and maybe you're covering this later in the stream. If you are, I apologize. But say I do see like weird spikes on my connections, right? And that's not a good thing. How do I go about like debugging, what's wrong or, why I'm seeing something like that?
Gotcha. Yeah. So if you're seeing weird spikes here, that's probably an indication that something is wrong. If you're paying for AuthZed Dedicated, we do have a support team, and that would be a time when I would go to open a support ticket, because ideally, like the machinery that we're running for AuthZed Dedicated should be managing this for you, and it should be balancing the connections appropriately. And if you're seeing spikes in connections, like the first thing that would make me think is that for some reason the SpiceDB pods themselves are thrashing, like pods are crashing and coming back up, or like something is over provisioned in a way that's unexpected. So that wouldn't be something that you would necessarily have a knob for. So I would recommend contacting support in that case. And then if you're running it yourself, I would be looking at like, are my SpiceDB pods stable? Is the number of connections that they're requesting under the number of connections that is available? There's a couple of settings that can impact how SpiceDB acquires connections. Like there's one that it's like data store connection jitter, and it's essentially that like the SQL client in SpiceDB will like acquire a connection, and it'll hold it for some period of time, and then it'll drop the connection and then acquire a new connection. And the idea is that like by refreshing connections over time, you're making sure that you don't end up with a connection that like can't do any work because of network connections or something like that. You're just sort of like refreshing the connections over time. And so if you're seeing a spike here, like another thing that I might think is that if the jitter is not set, or the jitter is set to 0, then that means that all of the SpiceDB pods that came up at the same time are going to drop and reacquire their connections at the same time, which will mean that you are like on some periodic interval, you're getting rid of all of the connections that you have to do work with SpiceDB and then reacquiring them. And so you're going to be likely paying a performance penalty while those connections are being reacquired. And I would expect that sort of spike to be visible in the connections graph as like, we've dropped a bunch of connections and then now we've reacquired them. Does that make sense?
Yeah, gotcha. Nice. All right.
Yeah. And this is like very much getting into the weeds of SpiceDB tuning. And again, this is something where like, if you get SpiceDB dedicated, this is ideally stuff that you don't have to think about, because we have already done a bunch of thinking about this and have built automation and machinery underneath it such that all of this is just kind of abstracted away from you. But it will be stuff that you have to think about if you're running your own SpiceDB cluster. Cool. So, and then like just like quickly going through these other graphs, free storage space, this is just make sure this number is not 0, or make sure that it's not trending quickly towards 0. If you're doing a big data load and you're heading towards 0, that's probably an indication you should have more storage. And then we have read and write, IOPS, throughput, and latency. So this can give you an idea, like if you have high CPU utilization, you're probably also going to see spikes in read and write latency, and that can be an indication that like this is CPU utilization is the problem. This read latency is contributing to your SpiceDB latency, and that's a problem to solve. So just kind of like having a scan of these and making sure that all of them are within acceptable bounds is a good thing to do when you're troubleshooting a performance problem. Any more questions on Datastore stuff before I move on to Materialize?
And I think this is a cursory, like just sort of me confirming, but all of these things will roughly, have like the same shape regardless of what data store you use, right? So if you're using Cockroach or Postgres or RDS
Yes.
or whatever, roughly the
Yes.
same shape is what you would look at. Okay. Yeah.
Yep. And if like Cockroach versus RDS, the only thing that's going to look different for this data store page is that instead of having like the IOPS for the entire like database instance, like if you're using Postgres, you've just got a single box, right? But in the Cockroach case, you're going to see this graph broken down by node, because each Cockroach node is going to be doing some work, serving some of the traffic. And you should see that they are like relatively aligned with each other. And if they aren't, that can be an indication that there's something going on with the underlying data store. But yeah, does that make sense?
Yeah, absolutely. Yeah.
Cool. Then yeah, let's step on to Materialize. And for those of you who are unfamiliar with what Materialize is essentially a like materialized view of your SpiceDB permissions. The idea is that you can say like, so if your system is often asking the question, can this user view this file? And there's like a number of hops in that computation. SpiceDB, when it does that computation, it's going to be walking that graph each time to answer that question. And there's a whole bunch of caching that goes on with SpiceDB that makes that more performant. But materializes the recognition that if all of this information is something that I can pre-compute in advance, then I can answer that question really, really fast. If I have some notion, if I just like have a list of like this user can see these files and this user can see these files, then it's just like an O of 1 type lookup, and you can get responses in like microseconds rather than milliseconds. And Materialize is our implementation of that idea. And so it's, you're taking all of the relationship data and you're taking a set of watched permissions, say like, user, view, and file. And you're then doing all of that pre-computation. And then it's also like, once it's done with the pre-computation based on like a snapshot of the relations that are in your system, it's going to start watching for new changes to the system. And each time like a new relationship or set of relationships is written, it's going to calculate the diff between the materialized view that it has and what it needs to be based on that new information that's come in. So that's the idea of the cache here. And these are the metrics that show you how your materialized cache is performing. So the thing to call out here is like, when you're looking at this RPS graph, you want this to be like, you want these numbers to go up. Essentially, the more throughput that Materialize is seeing, the better the performance of your queries is going to be. So if you see this go down, that can be an indication that like, hey, there's probably something wrong with your Materialize instance. And like, ideally over time, this is something that you are like working to increase the number of requests that Materialize can successfully serve. And so all of this is just kind of around that idea of like, this is the throughput that Materialize is seeing and serving. And then if you come down here to the update count and update lag, the idea is that update count is showing you for a particular time slice, like there have been a certain number of writes happen and then that have happened. And then there's a certain number of updates that have needed to happen to like Materialize's data as a result of those relationships being written. And this gives you an idea of how much work Materialize needs to do to keep up with the write throughput on your system. And again, this is something where like, it's going to depend on the shape of your data and the shape of your schema. So like a deeper schema will require more computation, more data likely going to require more computation. And if you see spikes in this graph, that can be an indication that like, oh, there's like one particular relation that has a whole lot of leverage, for lack of a better word. Like a single update to a single relation can cause many, many updates, and like understanding where those are in your system and making sure that like those aren't hit particularly hard, or like it might even be a reason to change the shape of your schema to get better materialize performance. But so this update count is like how much work is it doing? And then the update lag, this is like basically when a write comes in, how long does it take that write to show up in what Materialize is able to serve? Like how long does it take for a particular revision to show up in Materialize? And the big thing here is that you're going to, like when you're setting up Materialize, you're going to set up an acceptable amount of lag, like that you're saying it is okay if results are this, like this old, this stale. And this update lag needs to be less than that sort of max staleness number, because otherwise Materialize won't be able to answer the question because it doesn't have the results for that particular revision. So if this number gets above whatever your max accepted staleness is, I think for this system, we have it configured to 5 seconds. If it gets above that threshold, then Materialize is going to stop being able to respond to things. You're going to see elevated latency because then SpiceDB is going to have to do that work. And in a worst case, if SpiceDB doesn't have the capacity to serve all of your traffic, like if you're essentially leaning on Materialize for performance, then you can get a sort of thundering herd effect where like update lag getting above a certain point means a bunch of requests go to SpiceDB, means your whole system starts to slow down. So just paying attention to what this update lag is doing and making sure that it's comfortably under whatever your max staleness is a good thing to pay attention to. And that can mean like if you're having issues with that, there's a number of different remedies. If you can accept more staleness, you can bump the staleness and just kind of give yourself more headroom. We talked about like how you might change a schema so that relations have less leverage on it, for lack of a better word. And also like you can set up Materialize to watch multiple permissions. And what you might find that you need to do is like, if you've got multiple permissions that a single Materialize instance is watching and it can't keep up with all of them at the same time, then that might be an indication that you need to break up the work that is being done. So you have like one Materialize instance watching one permission and another Materialize instance watching another permission. So yeah, those are some things to think about when you're looking at update lag. Any questions on that or on Materialize in general?
Yeah, I actually have a question on Materialize. Before that,
Sure.
I just want to shout out an upcoming event. On August 20th, we're doing a bigger live event and we're streaming live. And it's called AuthZed is 5 because, as the name suggests, AuthZed will be turning 5. We have some exciting speakers. We have some cool things we'll be announcing. So yeah, just sign up there. Again, AuthZed is 5. Sign up and you'll get a reminder and a link for the event. It's online and it's free. Tana, question for you about Materialize. So say I'm a customer of AuthZed, I use SpiceDB, I have Dedicated. Is Materialize, do I need to do something to get Materialize running on my system? And how do I turn that on, essentially?
Yeah, so right now the answer is talk to us. We have, we do have plans to make Materialize self-service. The idea is that on this Materialize tab, there will be a create button and you click on it and you go and you like choose which permissions you want to watch and how many resources you want to dedicate to Materialize and which permission system it's going to be associated with. And then everything kicks off in the background. So you get a running Materialize instance. We're still working on the UI for that. So coming soon, TM. And in the meantime, give us a call and we'll do the work of setting it up for you.
Sweet. Okay. All right. And yeah, folks, if anyone has questions, feel free to put in the chat. Oh, we have a question from Karthike. Actually, before this question, I just also want to shout out Karthike, who's made like a bunch of pull requests to open source SpiceDB and also to the documentation and stuff. So yeah, really appreciate it, Kartike. Yeah, it's
thank you
always
so much,
nice when, when folks from the community contribute to things like docs and open source. I love that vibe. So the question here is Materialize conceptually similar to the Leopard indexing system in Zanzibar? From what I get, Leopard operates as a kind of black box reverse index in paper. Does Materialize serve a similar purpose?
Materialize is exactly that. It's our implementation of the Leopard cache. And yeah, to your point, there are very few details about how it works in the Zanzibar paper. And so there's been a whole bunch of stuff that we've had to sort of suss out and figure out and make sense of. Just as an example, originally everything was in memory, and then it was like, oh, well, if a pod rolls, then we gotta not have it all be in memory, because then it just blows away. And so then we had to figure out what database is actually appropriate for this workload. Turns out that's a really difficult question, and we had to go through multiple iterations before we landed on something that worked for us. So yeah, whole bunch of interesting work that went into that. But Materialize is our Leopard cache implementation.
Yeah, you were spot on, Kartike. So you are, yeah, absolutely, it is that. And yeah, once again, thanks for your contribs for SpiceDB.
Yeah. Okay, cool. So yeah, I wanted to talk about the Datadog integration. We have all of these metrics available in the console, but we know that you don't necessarily want to view them in the console. You want to view them in whatever your observability platform is of choice. So we do provide a way for you to scrape a Prometheus endpoint if you want to pull this into your own Prometheus system or your own Grafana instance or whatever. But for Datadog, we actually have a way that we can submit metrics directly to Datadog. And the way that you'll do that is you'll go to your permission system, you'll go to the settings tab on it, and you'll see that there's a panel for Datadog metrics. You'll put in your Datadog API key, and you'll put in your Datadog site, and then you click save. And I'm not going to do that right now because there's about a 5-minute lag where we're starting up some pods, and then the metrics are starting to flow, and then it takes a while for Datadog to start ingesting them. So we'll just go and look at what the dashboard looks like when you've got those metrics flowing. And this dashboard it's essentially all of the same graphs as you see in the metrics panels here, just in Datadog's way of phrasing them. And this dashboard is available when you install the AuthZed integration. So if you go to integrations, you search AuthZed, you'll see that there's this AuthZed cloud integration. Open it up and it'll give you some idea of how to do the configuration. And I think there will be a button to install it if it's not already installed. One thing that I'll call out is that if you go and you start submitting metrics from our side, there's a good chance that when you get over to Datadog, you'll see that this has been installed for you. And that's just a behavior of Datadog. If you submit metrics that are associated with an integration that Datadog knows about, then Datadog will just install that integration for you. That was something that surprised me when I was originally setting this up. But it comes with this dashboard, and you'll be able to see all of these same graphs. But then they'll also be correlated with, you'll be able to look at traces for that same time period and things like that. So yeah, any questions there?
No, I think that was very self-explanatory. And if I'm not mistaken, I think Datadog does behave that way, where if you add the API key, it installs it on their UI, basically. Yeah.
Mm-hmm. Yeah. Yep. Cool. Well, yeah, that was all that I had as far as content. Did we have any other questions or any other topics we wanted to cover?
Yeah, I think when we talk about OuthZed Dedicated, SpiceDB, metrics and stuff to devs and stuff, there are lots of questions around observability, and I think rightfully so. And Julian, who's our solution engineer, and myself, we collated some questions to ask you, Tanner. which we get quite often in situations like this. So I can just like quickly FAQ you, and yeah, you can just give me answers like this. I think the first one was having something like this, does that impact like someone's Datadog costs? Right. So say they're spending like a bunch on Datadog already on their cloud stuff and whatever. Does this impact those costs in any way?
It should not. And the reason for that is that when you have when you're submitting metrics that are associated with an official Datadog integration, they aren't considered custom metrics. So you're going to pay for custom metrics, and you're going to pay not just for like each metric that you submit, but each how do I put it? So like if you have a bunch of labels that are associated with metrics, or like a bunch of tags that are associated with metrics, then for each unique combination of metric name plus tags that you submit, that is an additional custom metric for the purposes of Datadog's pricing. But if you have an official integration, it's considered a standard metric and not a custom metric, and therefore should not contribute to your metrics costs. So if you're using Dedicated and you're using Datadog and you hook all this up, you shouldn't see your Datadog costs change at all.
Nice. And also just to clarify, it doesn't cost to also just enable this metric on Datadog, right?
Correct. Yeah.
Yeah. Okay. Nice. All right. So that was one commonly question that we commonly get. There's another question, which is, how do I know which permission system these metrics are for? Like assuming I'm running multiple, right?
Oh, sure. So let's go to our Explorer, and let's look at, say, let my keyboard wake up again. So gRPC server handled is that throughput metric that we were looking at. Nope. Come on. AuthZed Cloud. I've been through a couple of iterations of this thing. This is what it's going to come through as if you're just looking at all of them. The AuthZed permission system label. This is the label that tells you which permission system they're coming from. So if you want to see it broken down by just a particular permission system, you would add this filter to your to the metric. So like this overview is going to be for all of your permission systems, and you would need to like edit the breakdown to like point at a particular permission system if that was something that you wanted to do. It's somewhere in my backlog to add like permission system as a variable that you can just like select and then filter down. But this isn't something that I've gotten to yet. But once I do get to that, then I'll submit a new version of the dashboard, and that should automatically come out to anybody who's using this dashboard.
Nice. Okay. We have a question from Louis Landerman, or Louis Landerman, I'm not sure. But the question is, does the Datadog integration include other types of ingestion, like logs, in addition to metrics? Which, thanks for teeing me up, Louis, because a question I was about to ask was, does this also send like logs and traces? Right? So I think this is a question that we get asked quite a bit as well.
Yeah, and the answer is not currently, but that is something that we want to do in the future. It isn't currently scheduled, so bug us.
Yeah, coming soon, TM, as Tana said, but yeah. Okay, cool. Yeah, and thanks for joining the stream, Louis. And yeah, I think another question that we'll probably get asked, and we're sort of preempting it, is, do you plan to support other observability vendors like New Relic and Dynatrace? And there are a bunch out there as well, right? And so say I'm already using one of them, what can I do?
So that would be another sort of like soon TM thing. Datadog is the one that we heard the most about, and so it's the one that we focused on initially. from a technological perspective, the component that we're using to submit these metrics is the OpenTelemetry collector, which supports lots and lots of destinations for forwarding metrics, Datadog being one of them. And like, because we're using that, it should mean that that in the future, it isn't difficult to add additional targets, like an additional configuration, additional destinations, that kind of stuff. But that isn't something that we currently have on our roadmap. So again, if that's something that you want to see, come talk to us.
Yeah, and the thing that Tanner was speaking about, it's in our docs. So if you go to authzed.com/docs, just check out the observability page. There's stuff about telemetry, OTel, all of that, profiling, and all of that. So yeah.
Yeah, I can look at that real quick. No, SpiceDB, concepts, operations, observability tooling.
There we go.
And this is more focused on like if you're running SpiceDB yourself, but like some subset of this is exposed as like the metrics that you're getting in Rakus or in the AuthZed Cloud Console and in the Datadog integration.
Cool. So we're almost out of time, so I'll leave maybe a couple of minutes if folks in watching here want to ask questions. Another question that, I mean, you of course covered most of this, Tanner, but I'm going to ask it anyway, which is, say I've just sort of started on this journey of having a permission system, SpiceDB. What are the metrics I should care about the most so that you can set up monitoring and alerting for AuthZed Dedicated?
Yeah, that's a good question. So I would say, like, as far as just like health of my system, is it performing the way that I would expect it to? The latency is one of them, because when you're using a centralized authorization system, like this is on the hot path of every single request that's coming into your system. You want to have an idea of sort of what your tolerable latency is. And like, I would recommend having an SLO around that like having an SLO for the latency that SpiceDB itself is adding to the system. And then if that goes above a certain point, then that's something that you want to pay attention to. Node CPU and memory, those would probably be good things to, well, yeah. Now we're getting into the like, every alert should be actionable, so what do you actually alert on kind of thing. So maybe I won't speak directly to alerts because it's going to depend on your organization and kind of how you've conceived of your SLOs. But just being aware of like the CPU usage of SpiceDB and whether you're bumping into limits there. And then I would say the Datastore CPU utilization and connections are the other two that I would really focus on. If you're seeing degraded SpiceDB performance, there's a good chance that it has something to do with the Datastores utilization and connection utilization.
Sweet. Awesome. Yeah, I think that's pretty much it, Anna, unless there's anything else you want to talk about.
There was something that rang a bell with Datadog, and now I can't remember what it was. So I'll just have to document that when I think of it.
Yeah. We did briefly say we should talk about like the PGX connections, weighted connections thing. Is that something we should chat about, or we can,
yeah, that's like kind of digging in a little bit further than the stuff that you would see in this dashboard. But remember when I was talking about like this connections metric, the metric that is most specifically going to give you some idea of whether SpiceDB is waiting on connections is going to be this PGX. No. Also Cloud PGX weighted connections. This is like in a given time period, how many connections had to wait to acquire. Like basically PGX is like, this is the driver that we're using to talk to Postgres and CockroachDB. It has a connection pool whose size is determined by those flags that we were talking about. And so when a request in SpiceDB wants to go to the data store, it's first going to go to that connection pool and it's going to say, hey, can I have a connection to make this request? If it has to wait, like if there aren't currently any connections available, then that is going to show up as like there was a, that's going to be an instance of a connection that had to wait, according to this metric. And anytime that wait is happening, that's latency. That's a latency penalty that you're paying that you theoretically don't need to be paying. So like what you're seeing here with there being a good number of waiting connections probably indicates that this Thumper cluster that I've been looking at isn't running optimally. So I'd want to go and look at the number of connections that are available in my data store and the number of connections that are configured on the instance and make sure that those numbers line up. And if I'm still seeing these waits, then that might be an indication that I need to scale up my data store, because the size of your data store is what determines the number of available connections. So yeah, this isn't something that is in the dashboard currently because it is kind of a wonky metric, but it is one that is important and useful.
Nice. All right. So I think we're out of time. First, Tana, thank you so much again. That was wonderful. And of course, this video is going to be on YouTube and even in our documentation. So at any point of time, if you want to revisit it, you can do this. 2 quick shout outs. If you haven't subscribed to our YouTube channel already, what are you doing? Do it right now. And 2 weeks from now, we're doing another live stream, which is about the new AuthZed Cloud Terraform provider. So you can actually automate provisioning of your permission systems using the Terraform provider. Sertruda, thanks for hosting this. Look forward to more. Thank you so much, Sertruda. Join us 2 weeks from now, where Veronica will be talking about our new Terraform provider. And yeah, if you have any questions, anyone join us on our Discord. And until then, enjoy playing around with SpiceDB, and we will see you soon. Tana, thanks again.
Absolutely. Thank you.